So hello, my name is Elisabeth. I'm a grad student at UCSD, and today I'm going to present a project entitled How Reliable is Give-a-Number Task. All right, so give-a-number is a task that is frequently used in mathematical cognition to assess children's understanding of number words. So this task became popular after the 90s because it was seen as a more informative alternative to the then commonly used task, the how many task, in which children were simply asked to count a set of objects and could therefore use heuristic to succeed without actually understanding number words. So in the give-a-number task, there's an experimenter who asks the child to provide a certain quantity of objects. So the experimenter says, for example, can you put 2 cookies in the bowl? And the child who has counters will provide the object in the plate. Okay, so using this task, researchers were able to show that the acquisition of number words follows a progressive trajectory. So first, children are able to recite the count list, but without actually attaching meaning to the different number words. So for this reason, children at that stage are called non-knowers or zero knowers. Then children develop an exact meaning for one, meaning that they're able to give one object for requests of one, but they can't give reliable responses for larger requests. And so children at that stage are called one knowers. Then children become two knowers, meaning that they can provide 1 and 2 on the request, but they won't give reliable answers for larger requests. In a couple of months later, children become 3 knowers and then 4 knowers following the same pattern. And then after going through these subset knower levels, children seem to realize that the last number word used when counting refers to cardinality of the set or the total amount of object in the set. And this is why children at this stage are called cardinal principal knower. So a reason why given became this type of gold standard in the field is because this basic pattern of acquisition that was demonstrated using give-a-number tasks has been replicated consistently across different labs and across different languages. And so this is great news for developmental psychologists because the knower levels can then provide a theoretical framework to be used as a predictor and correlate of other aspects of development. So for example, vocabulary size. However, the replicability of the knower level framework does not itself assure that the reliability of individual knower levels, and that is critical in order to use those in correlation and obtain interpretable results. And so currently, the test-retest reliability of given is not known. So what makes the question of reliability harder to address in the case of give-a-number is that there's important amount of variability in how the task is administered across labs. So importantly, labs differ in the versions of given use. So either the titrated and non-titrated version, which I will explain in the next slide. And right now, these versions are assumed to yield the same outcomes. And the testing environment, so either in lab or out of lab, also differs across studies. And the goal of our project is to assess the impact of these factors on the reliability of given. So what is the difference between the two versions or ways of administering given? So the titrated version is comparable to a staircase task administration in the sense that the requests for object depend on the child's pattern of response. So if there's a success, the experimenter asks for the following larger requests. So in this case, the experimenter could start at 1, and then if there's a success, ask for 2, and then ask for 3. And if there's a failure, the experimenter asks for the previous request. So he would go back to 2. And so this pattern is repeated until the experimenter satisfies the criteria to assign a knower level. This criteria I will explain in the next slide. The non-titrated version is much more straightforward in the sense that the requests are fixed and the experimenter, based on the child pattern response, can then attribute a knower level. So to assign a knower level, these are the criteria that are frequently used in the literature and that we also use in our experiments. So first, the child needs to succeed at a number n 2 out of 3 times for request for that n. There need to be at least 2 out of 3 times failure at n plus 1. And also n can't be used for requests other than n too often. And children are credited as CP knowers in one of 2 ways. Either they follow the pattern described before, or they succeed on all the requests of 1 to 6 consecutively without error. Okay, so in this project, we assessed the reliability of given, and we did this through 3 experiments. So in experiment 1, we assess the test reliability of given titrated. In experiment 2, we assess the test-retest reliability of given non-titrated. And in both experiments, we asked whether there was an effect of testing location, so either in lab or out of lab. And finally, in experiment 3, we assess both versions of given within children, and we compare the outcomes of the two versions to that of another task often used to assess number words understanding, namely what's on this card. Okay, so for experiment 1, we tested 81 children who are aged in average 3 years old, and these children were presented with 3 tasks. So given titrated the first time, then a counting task, and then given titrated a second time. So as for the results, so this graph displays the NOAA levels obtained in the first assessment, so in the x-axis, and in the y-axis, it's the NOAA levels obtained in the second assessment of given. And the numbers in the cell represent the number of children with a certain type of NOAA level combination. So for example, the top cell on the right, right here on the right corner, suggests that it shows that there were 22 children who were classified as CP knowers both after the second assessment, after the first assessment and the second assessment of given titrated. And so we also use colors to code the density. And what is important to notice in this graph is that the density or color is highest on the diagonal. So right here. And so this is good news because it suggests that there is a high concordance between the NOAA level of the two tasks. And so we also measured the Cohen kappa, the statistics to assess the reliability, and we obtained a pretty high reliability of the task overall, so 0.87, and the theoretical maximum is 1. So, however, as you can tell by just looking at the graphs and the color and diagonal, there seems to be a lot of variability in the reliability depending on each NOAA level individually. So we looked then at the reliability of non-knowers and CP knowers. And so, so what we found is that both were very high. And so this means that children who were classified as either non-knowers or CP knowers in the first assessment were really likely to receive the same NOAA level in the second assessment. And so what is interesting is that that wasn't the case for kids within subset knowers. So for those, the reality was much more nuanced. So it was quite high for early subset knowers, like 1 and 2 knowers, but much less for 3, 4, and 5 knowers. However, when we look at NOAA level groups, so 0 knowers together, all subset knowers together, and CP knowers together, we found that the reliability was much higher. And so children who were classified as subset knowers in task 1 were likely to be classified as subset knowers in task 2. So thus far, we found that given number task, the titrated version is highly reliable when all NOAA levels are considered at once, but that there's variability in each NOAA level. However, the reliability was highest when we look at NOAA level groups, meaning that classifying children as either non-knowers, subset knowers, or CP knowers is perhaps the more cautious way of assuring the reliability compared to individual NOAA level stages. Okay, so in experiment 2, we had the same design as in experiment 1, but with the non-titrated version of given. And we tested 81 children, and they were presented with 2 non-titrated tasks with a counting task in between. So for the result, again, we obtained a high reliability when all NOAA levels were considered at once, 0.8. And just like the titrated result, this high reliability could have been driven by the high reliability of 0 knowers and CP knowers and perhaps early subset knowers. So we found that the reliability of 0 knowers and CP knowers was quite high. And within subset knower, however, the reliability was again weaker. But subset knower as a group was highly reliable. So overall, the results of experiment 2 are conceptually very similar to experiment 1. The non-titrated given is highly reliable, and taking NOAA level group instead of NOAA level individually might be a more cautious way to preserve reliability when used as a predictor in analyses. Okay, so to answer a question of whether there's an effect of testing location, there was none. So we've seen so far that both versions of given have a high test-retest reliability. And the question that we address next is, would they generate the same NOAA level within the same child? Or perhaps does one version has a bias to generate higher NOAA levels? And so this is the first question that we asked in experiment 3. Our second question in experiment 3 was, which version should we use as researchers? How can we decide which one provides a more valid output? And to address this question, we compared the outcomes of these two versions of given with that of what's on this card. So in experiment 3, we tested 75 children, and they were presented with 4 tasks, given titrated, a counting task, given non-titrated, and what's on this card. So in what's on this card, an experimenter presents children with a picture containing a certain number of objects and asks how many objects there are and encourage the child to count the object. And the experimenter can then assign a NOAA level based on the same criteria as given. So we first look at the result of given titrated versus non-titrated. So how reliable are their output? And so we obtain here a kappa of 0.71, which is relatively high, but still lower than in experiment 1 and 2 when we look at the two versions of given individually. So when we look at NOAA level individually, again, the kappas of non-knowers and CP knowers were high, but definitely decreased when looking within the subset knower group, and it was actually 0.5. That being said, the reliability of subset knower as a group was high, which is good news. Okay, so if we take a closer look at at this comparison, there were 45 matches and 30 no matches. And if we look at the graph here, that plots a distribution of differences in NOAA level across the task in the x-axis. So positive number mean that the titrated NOAA levels were higher than the non-titrated NOAA levels, and the negative numbers means that the non-titrated NOAA levels were actually smaller than the titrated NOAA levels. And so interestingly, the majority of the no matches differed by only one NOAA level. And this difference was in favor of the titrated version. So this means that the no matches were composed mostly of children who were classified as having, in the titrated version, one NOAA level above that of the non-titrated version. And if we take the reliability result into account, these children were more likely subset knowers. Okay, so even if the two versions of given had a reasonably high reliability, the titrated version still generated slightly higher NOAA level. So the question that we ask next is, which version is more valid? So how do these results compare to what's on this card? So when comparing what's on this card in the titrated version, we observed that there were 33 matches and 42 no matches, which is a large amount of no matches. And when we compared what's on this card and the non-titrated version, we found 37 matches and 38 no matches. So when we look at the distribution of differences between the titrated and non-titrated, we found that the what's on this card generated higher NOAA level here on this graph, and not just by one NOAA level, but also by 2 and 3 NOAA levels as well. And the results are pretty similar when considering the difference between what's on this card and the non-titrated given. What's on this card generated higher NOAA levels, and the distribution of differences, again, was quite spread out. Okay, so to conclude, experiment 1 and 2 showed that both given versions individually have a high reliability, but that is somewhat nuanced for late subset knowers like 3 and 4. And using NOAA level group instead of individual NOAA level might be a better way to preserve reliability. There was also no effect of testing environment. In experiment 3, we found that the reliability of both given versions when tested together was pretty high. And when comparing these results to what's on this card, we found that the NOAA levels of both given seem to differ from what's on this card. In fact, what's on this card consistently generated higher NOAA levels, and not simply by a difference of one NOAA level, but sometimes 2, 3, and sometimes 4. And so in terms of which version of given to favorize, well, given that they generate, the titrated and non-titrated version generate NOMA levels that are somewhat similar, it could make more sense to use the titrated version as it is faster to administer and therefore more appropriate for younger children. In addition, using NOMA level group, so zero knowers, subset knowers, and CP knowers might be a best approach to maximize confidence in the results. Right, so I would like to thank the Cognitive Science Society for this opportunity to present my work, and members of my life for their support and input, as well as our funding agency. Thank you.